Hey guys, welcome back to AlgoYogi. We are doing two pointers series, and our next problem in the list is assign cookies. Let's visit the problem on LeetCode. So description says, assume you are an awesome parent. Yes, all parents are, except some dicks. And want to give your children some cookies. Not a good choice, I wouldn't do it. But you should give each child at most one cookie, and each child I basically has a greed factor GI. So basically they want to get more cookies, or they know these are the minimum cookies that we want, and if we get that many cookies, like, we'll be satisfied. So which is the minimum size of the cookie that child will be content with, and each cookie J, which is in our S array, so that's like the size of the cookie, and G is the greed factor of the kids, basically ith index. So they're like, size of G is basically the number of kids, S is basically the number of cookies, and its size basically, and it should be basically lesser than it can be bigger than, more than the kids, or it can be lesser than. So they haven't told us that, so it's not given over here. Now our goal is to maximize the number of content children and output the maximum number. So it's like using whatever cookies we have, how many kids you can satisfy. Okay, so with the cookies. All right, so now let's see how we're actually going to do it. Let me switch the view here. So first example says that we have three kids, and we have two cookies. Okay, size of the cookie is 1 and 1, and now we know that there is one kid that wants cookie 1, another kid wants cookie 2, the second 0, 1, 2. So this is the index when child 1, 2, 3. There are 3 kids, and third kid wants basically 3 cookies. Now, do we have it's basically the size of the cookie, or you can say like 3 cookies together mashed up. It doesn't really matter, honestly. What I mean to say is, like, size of the first cookie is just 1, second cookie is also 1. So we can only satisfy one kid, right? We can't satisfy like any more kids. So our output would be basically 1, because output 1 means we could only satisfy one kid, because we had 2 cookies of size 1, and there was only one kid that has the greed factor of 1. So we could only satisfy this pair, right? So let's see how we are actually going to solve this. And we can see in the second example also over here, second example, the greed factor is basically 1 and 2, and then we have cookies, 3 cookies this time, and only 2 kids. So we can satisfy both kids, right? So what I propose to find the best solution for this is using two-pointer approach. Basically, first is, we know we can only satisfy the minimum kids, or the max kids is the size of our cookies array. So it's like that's the number of kids we can satisfy. This is the max, okay? And that too, it only gonna come down because we might not have enough the size of the cookie to basically satisfy the greed factor. So what we are actually going to do is, we are gonna iterate over our array from back. First, we're gonna sort these arrays. Okay, let's sort them. First, we sort our arrays, and then we iterate over our array, and we check if, because this will also be sorted, it hasn't guaranteed to us that these greed factor and the size of the cookie will be always, like, in an increasing order. That's not given to us, so we will sort it ourselves. They're already sorted in the examples, in both these examples, but they might not be. Once they're sorted, which they, in these 2 cases they already are, then we have our, basically I will basically be iterating over my G, and then in my size I'll be pointing a pointer, let's say P, to the S, and I check if is this kid's basically greed factor is greater than or equal to my size of my cookie. If it is not, then keep looping, keep going here and keep going here. This will be the kid that will be satisfied by this one. So these two are done, and then a greed factor, basically we are done with the kids, and we haven't even utilized all the cookies. But in this case, if P is pointing over here, then we check 3 is greater than this, so result basically 1. Then my I comes over to this one, and this again P is moved over here, and then this is also greater than 2. So sorry, greater than 1. 2 is greater than 1. Basically, size of the cookie is greater than the greed factor of the kid. Then we can add one more to our answer, and then we ran out of the kids. No more extra cookie remains, and then result is basically 2. So it's like we use a for loop to iterate over from back on the sorted G and then sorted S as well, but we only decrement P and increase the size of our, you know what, we could actually sort them in reverse order, and so that we don't have to actually iterate our G and S in basically from the back. We can just iterate it from the front. All right, so let's do that. And I think to reverse an array is quite easy, I guess. So let me change the view. Looks pretty good. Okay, so let's sort our arrays first. So I'll say G dot sort, and I think it's like there's something here we pass. I think it's reversed. So let's check it. Sort array Python reverse. So I think it will give us, so reverse equal to true. If we mention this, I think that's when it will give us. So these are the things that sometimes we might forget, so it's okay to check. All right, I think interviewers should allow these. All right, now it was such an easy thing though. I just remember I've been coding in like Java and JavaScript, TypeScript, or whatever. They're same thing. Okay, not Java and JavaScript. JavaScript and TypeScript, they're basically same thing. Java's different. Okay, so this is done, and same thing with S. If it's true. Now what we want to do is we want to loop over my G for I in range G, length of G, and now I want to check. I have result or P basically pointing to I would say 0 in the beginning, 0, and then I want to check if this particular cookie I'm pointing to, its size satisfy the kid that has the most demand, most greedy kid we have. So it's like, and this is the biggest size of cookie we have. If that can satisfy, then we basically increment P. Otherwise, we basically remain at P, but we try to find a child that has less demand. Okay, so if G size is basically lesser than or equal to size of at the pointer P, if that's the case, then we basically increment the P. Otherwise, we do nothing. And then we also check here that the P is basically less than length S. Okay, that's when we want to check. Otherwise we can't keep incrementing the P, because P can only go up to the size of the cookie. Okay, but G can be very, very long. Okay, and this, and then finally we can just return P. Otherwise we could have just had an extra result thing, and then we could have resulted like return that. But since p is only incrementing if that cookie could satisfy any of the kid, so it only increments from the back, and we would rather prefer a kid to have, like the biggest, and which biggest cookie, the biggest greedy kid. Okay, so I think this should be okay. And let's, this is an experiment, this is the first time I'm solving it, so I really hope it works. It does, and on examples it definitely does. This is a check, good check. Okay, 90%, that's really good. That's a good solution. Given these are the easy problems, they have been solved by so many problems, beating 90% is still good. So let's write the time complexity. So that will be big of n log n, and that's because this sort is worst case n log n. This is just iterating the g size n. N is the size of the array, the biggest array of g and s. Okay, and then space complexity is basically big of 1 because we're not using an extra size, we're sorting the arrays and then just iterating over them. That's it. All right, let's go back to AlgoYogi and mark this problem also solved, assign cookies, and see you guys in the next problem. Until then, bye bye.